Good afternoon, class. Today what I'd like to do is to conclude our series of videos on chemical bonds by talking about covalent bonds. Covalent bonds, by definition, are bonds that occur when two or more atoms come together and they share valence electrons. So kind of like the chemical bonds with single, double, and triple chemical bonds, those are kind of covalent, but they are more in the category of single, double, and triple. Covalent bonds generally form when you have different elements of, different actual atoms that are combining together. Those are what we would call more covalent bonds. So in this case, one atom is not more powerful than the other, or the difference is not so strong that they can just rip the electron away like they did in ionic bonds. So in the case that I have right now, I have H2O or a water molecule. So in this case, because there's two separate hydrogen atoms, I made this hydrogen atom's valence electron a triangle, this one an X, and then the dots are the valence electrons for the oxygen atom. So when they combine, what you get is oxygen will combine with the hydrogens, and now you've got these lone pairs over here. And so if you notice, they're not in a straight line like I had in my last video, or in the first video in this series, where everything was in a straight line like so. It was just, now these are at an angle. And the reason for that is because while the hydrogen atoms are very much wanting to share the oxygen's unpaired electron, those lone pairs are trying to push all the other valence electrons as far away as possible. Essentially, they're basically like, brothers who are saying, no, we're good as a family, but all the other families need to stay away. They're trying to keep other lone pairs away. So they tend to push further away than other unpaired electrons. So the unpaired electrons of the hydrogen and the other hydrogen combine with the two unpaired electrons in the oxygen. The lone pairs try to push them a little bit more, so you get this more like a triangle shape, so roughly about 60 degrees. Depends on how strong, that depends on how strong the bond is. This is not always true with other types of covalent bonds, obviously, like carbon dioxide, carbon monoxide, those kinds of things. But because those lone pairs are so strong, and you've got two separate hydrogen atoms here, and also the fact that over on this side of the hydrogen atom, there are no electrons because they're all getting shared over here with the oxygen atom. So this side of the hydrogen atom is actually quite positive. So that's why these lone pairs can't push them completely to the side or something like that, because if it was up to the lone pairs, they would be over on the sides like this. They'd be over on these sides of the oxygen atom as far away as they could. But those hydrogen atoms also have very strong positive charges that are pushing against each other and pushing each other away from each other. So that's where the balance comes in, where they're basically about 90 degrees apart from each other, maybe about 60 degrees apart from each other or so, because those lone pairs are a little bit stronger than the hydrogen atoms over here. But of course, we don't want to write this out with all these different types of dots every single time we write out a chemical compound, a molecule, or anything in a chemical reaction. So what we do is we use again our notation, and we make this a single. We see there's a pair of electrons here to one atom to another atom, so that's a single bond here and here. So that's what a covalent bond looks like. This is probably the most complex of all of them, because more chemical molecules and chemical bonds form with covalent bonds rather than ionic bonds. And especially because they're also the more stable of them. So the ones you find in nature tend to be more of these kinds of covalent bonds than ionic bonds, because those tend to break up a little bit quicker. So that concludes my introduction on covalent bonds, and this also concludes the series on chemical bonds. So good luck in your studies, and may the force be with you.